There is a second formula for finding the derivative. That formula is here, and I know it doesn't quite look like it is, but this is a formula that's also derived from the slope formula that you learned back in the day in early algebra. So where this comes from, if we had the original formula for slope we were working with on the other problems, if we manipulated it, if we let the denominator of the other formula, the denominator is just x minus a, if we let that be this new thing h, we would be able to rewrite the original formula so that it looks the way that we see it on this page here. And that's just some algebraic manipulation, and the reason why we might want to use this second formula is because of what I say right in here. It usually simplifies really well. So this formula, it can be a little harder to set up, but it's usually a little bit easier to simplify. So if we take a look at this problem and we try to set up the formula. So it's a similar idea with when we're given this value for x equals 1, we actually plug that in for a for the same reasons as before. This is the point that I'm focused on. A is the point that I'm focused on. So this is the point that I care about. So if I start by plugging 1 in for a, I have the limit as h goes to 0, f of 1 plus h minus f of 1 all over h. So there are two pieces in the numerator that we have to plug in, again, just like before. They do look different. Well, the f of 1 doesn't look any different, but the f of 1 plus h does look a little different. So we know that f of x is 2x squared plus 4x. If I'm looking for f of 1 plus h, and this is going to rely on your comfort level with functions and function notation, but whatever's inside the parentheses, that's what we plug in for the x value. So I know that I'm going to need f of 1, so if I'm looking for f of 1, whatever's inside the parentheses, I plug in for x. It's the same thing here. I'm looking for f of 1 plus h. I plug 1 plus h in for x. So it's a little longer, and it's not as neat. We don't get a nice clean number like we do with f of 1. We get an expression instead. So this whole expression here, this whole thing, that's what I'm going to plug in to f of 1 plus h. So f of 1 plus h is 2 times 1 plus h squared plus 4 times 1 plus h. So that whole thing is just this first part of my setup. I have minus f of 1. So minus f of 1 is minus 6. We found that over here. This whole thing is divided by h. So we have another limit statement. And the hardest part on these is setting them up. Once we set them up, now this is a limit that we can solve by expanding the parentheses, by multiplying it out. Just make sure when you do this, so I'm taking the limit as h goes to 0. Make sure for any expression like this 1 plus h squared, make sure that's something that you FOIL. That's really 1 plus h times 1 plus h. Don't skip the FOIL step. So that would be 1 plus 2h plus h squared. If I distribute the 4, I have plus 4 plus 4h. And that minus 6 is still there on the end. All over h. Now I'm just simplifying. So 2 plus 4h plus 2h squared. Plus, I could combine the 4 and the minus 6, so I'll do that. I'm going to have a minus 2 on the end instead. All over h. This plus 2 and this minus 2 are going to cancel out, and we're going to find that on every single one of these problems. No matter what, the constant term should disappear. If you get to the step and you still have constants left over, the most likely mistake is that you did not distribute a negative somewhere. So go back and check your signs. Here, let's see what I have. I have 4h plus 2h squared plus 4h, so I'm going to write 2h squared plus 8h. My goal is to reduce these limit statements, and luckily I can factor an h out of the top. I should always be able to. So I am left with the limit as h goes to 0 of 2h plus 8. If I plug in 0 for h, I get the answer that I'm looking for. For this problem, like the other problems, I think you should pause the video, you should try the problem on your own, and then check back in with the video for the answer and the solution. So go ahead and pause the video now. The solution for this is 18. This does equal, it's the same function and the same value for x that we did in one of the other exercises, but we are going to do it in a different way. So we are going to have the limit as h goes to 0, f of 3 plus h minus f of 3 all over h. So that doesn't look much like a 3, but I promise that's a 3. So if we go and look at our function, we know we need f of 3 plus h. We know that we need f of 3. I'll find f of 3 first. It's a little bit easier. So f of 3 is going to be 3 times 3 squared minus 2. And we did already do this on another problem. We got 25. F of 3 plus h is going to be a little more complicated. So this time my function has 3x squared minus 2. So I'm going to have 3 times 3 plus h squared minus 2. I can simplify this now before I plug it in, or I can plug it in and then simplify. It does not make any difference at all what you prefer to do. I tend to put it in and then simplify for no particular reason. But let's work with this. So I have the limit as h goes to 0 of 3 times, don't forget to FOIL, that's 9 plus 6h plus h squared minus 27 all over h. If we distribute that 3, I have 27 plus 18h plus 3h squared minus 27. I can see that my constant terms, my 27s, are going to reduce, which is good. That's a good sign because we want that to happen. So what I have left, I know that I'm going to have to reduce this by h, so I'm going to go ahead and factor my h out now. I have h times and then 18 plus 3h, which reduces. So we have the limit as h goes to 0 of 18 plus 3h. So if I plug in 0 for h, I'm going to have 18 plus 0, which is just 18.